Okay, so today's video we're going to be looking at place value with decimals. We're going to be looking at comparing and ordering numbers with decimal points, and we're going to be creating a very large place value grid. And you can use anything that you find in the garden, in your house, in your kitchen. I'm going to be making my place value grid using some sweets. Okay, so as I mentioned, we are going to be looking at ordering decimal points. We're going to be going through a few examples. These questions always usually come up in Year 6 Sats. Okay, so these are the three numbers we're first going to be representing on our large place value grid. Okay, so before we look at comparing numbers, we're just going to be representing them. So the first number is 3.12. So in the number 3.12, we have 3 ones, as you can see. And then we've got 1/10. And then we've got 2 hundredths. So 3.12, 3 ones, 1/10, and 2 hundredths. Okay, so we've represented that using our sweets. So I'm using my largest sweets to represent my ones, and followed then by the tenths, and then my smaller sweets would be the hundredths. So 3.12, and I don't have any thousandths. It's important to remember that my ones is the column with the largest value, followed by my tenths, followed by my hundredths, and of course thousandths would be the column with the smallest value. Okay, let's have a look at another number after 3.12 so we can compare it. So the next number we're going to be looking at is 3.16. So in 3.16 we're going to be representing the number again using sweets, and then we'll compare it against 3.12. So in 3.16, of course, there are 3 ones. Then we need to look at the next column after the ones, which is the tenths, and there is 1/10. And then in the hundredths column, there are, of course, 6 hundredths. So I need to put 6 sweets in there. So 1, 2, 3, 4, 5, 6. So 3.16 we've represented. So now we're ready to compare both numbers together. So in the ones column and the tenths column, they've got the same digit, but in the hundredths they don't. So when we compare numbers, we look at the column with the largest value, which is the ones, and they happen to be the same. And then we look at the tenths, and then we'd look at the hundredths. So as we can see here, 3.16 is larger than 3.12, as there are 6 hundredths and only 2 hundredths in 3.12, because the ones and the tenths are exactly the same. So we've got 3 ones, 1/10, and then the only difference in both numbers is in the hundredths column. Okay, the next number we can compare with them is 3.085. So I'll put my decimal point down between the ones and the tenths. So in 3.085, again, we're going to start with the ones. And we can see also in 3.085, it's the same as the other two numbers. It also has 3 ones. Then we're going to look at the next column with the largest value, which is the tenths column, but there aren't any. So the hundredths column, we can see there are 8 hundredths. So 1, 2, 3, 4, 5, 6, 7, and 8. So far we've written 3.08. So what's different about this number is actually it has 5 thousandths. I need to move that out the way. The other two numbers didn't have any thousandths, but this one does have 5 thousandths. So I need to find even smaller sweets to represent my thousandths column with. So 1, 2, 3, 4, and 5. So they're my 5 thousandths. So I've done 3.085 to represent my number. Okay, we can now compare all three numbers together. So 3.12, 3.16, and 3.085. If we look at the column with the largest value, the ones, all three numbers have got 3 ones. So now we need to look at the tenths. So 1/10, 1/10, and 0/10. So that tells us that 3.085 must be the smallest number because it doesn't have any tenths. It has 0/10, whereas the other two numbers both have 1/10. So we now know that 3.085 is smaller than the other two numbers. First we compared the ones and then we compared the tenths, and that told us that 3.085 was smaller. Okay, so we don't have to look at that number anymore. We're just going to compare the other two numbers. So we've got 3 ones, 1 tenth, 2 hundredths, but 6 hundredths. So that would tell us that 3.16 would be the larger number out of the three numbers. Okay, so now we've got 3.16 as the largest number and 3.085 as the smallest number. So now we are able to order all three numbers. Okay, if you want to have a go, you can press pause now, and these are the 5 numbers we're going to be comparing. I have written them in different colours, so the ones are in blue, the tenths are in lime green, followed by the pink for the hundredths column and the light blue for the thousandths column. So if you want to press pause, have a go at ordering them, you can do, or keep watching and we'll do them together. So the first thing we notice that's the same in all of these numbers is that they all have the same value when it comes to the ones. So all of them have got 7 ones. So just by looking at the ones, that's not going to help us. So we need to look at the tenths column. So I can sort of group these numbers. So you've got the ones with 1 tenth, and then 2 tenths, and then 3 tenths for 7.31. So just by looking at the tenths column, we know that 7.31 must be the largest number out of all 5. So I'm going to leave that one at the bottom. So we've looked at the ones, we've looked at the tenths. So now I need to compare the ones that have got 1 tenth. So 7.186 and 7.114. So after we look at the tenth, we then look at the hundredths, and I can see that 1 hundredth, so the digit in pink, is smaller than 7.186, which has 8 hundredths. And then again, I'm going to look at the hundredths for 7.25 and 7.22, and I can see that 2 is smaller than 5. So now that we've ordered them. So remember, you always start by looking at the ones, followed by the tenths, followed by the hundredths. So we could also use some sweets or some twigs if you're outside as a number line. And once you've had a go at ordering the numbers, you can check them just by placing them next to each other on a large number line. I'm just using some small paper clips.